Let's talk about another no arbitrage model, the Black-Derman-Toy model, and also the Black-Kaczynski model. So the Black-Derman-Toy model, although they published as in the form of a binomial tree, essentially that model is a short-range model that follows this particular form here, where you have a sort of a mean reversion factor here as well. And here, the parameter of theta is not a, well, theta is not a parameter anymore. It's basically a function of time. And also this part allows them to match the initial interest rate. But in that model, there's a restriction that this A here must be a function that's related to the volatility term, okay? Again, their model matches the initial term structure of interest rate, and it can have multi-factors here as well. And later on, Black and Kaczynski, they published another paper, which basically is an extension of this Black-Derman-Toy model, where this restriction, which is actually in some way bothersome, is removed. So the Black-Kaczynski model essentially follows the same process, but it doesn't require this restriction to be there. The advantage of this is that they have the mean reversion explicitly built in here, and they match the initial term structure of interest rate, but both of these two models, there's no closed form solutions that we can use as before. So in the case of the Ho Li and the case of Hall-White one-factor model. We talked about the importance of matching the initial term structure of interest rate for to price options on interest rate options or options on zero coupon bonds and those or options on underlying assets that are functions of interest rates. But the other factor related to those options is the volatility. So matching the initial term structure of interest rate is only one aspect of that. For options, we also have to be mindful of the volatility structure. And in particular, if you look at the volatility structure compared to the maturity time of the options, that in the market, that structure can be of different shapes. Whereas if you look at just the Ho Li model and the Hall-White one-factor model, they have a very profound structure it has to follow. So for Ho Li, the volatility structure has to be constant. And for the Hall-White one-factor, you can actually have a downward sloping volatility structure there. But neither curve, neither one, you have a hump. So essentially for any one-factor model, you wouldn't really have a hump. But if you have a multi-factor model, you then have flexibilities in producing the volatility structure. So if you were to look at something like this, and if you build this a multi-factor model, and because you have here you have a particular a function of time, and then you can build in a volatility a multi-factor here. So for Black-Derman-Toy and Black-Kaczynski, you can actually have flexible volatility structures that probably matches the observed market much better. So it's really where you make a choice, right? Because on one hand, you have models that are relatively simple analytically, give you a closed form solution, allows you to do an all of analysis, and it's very easy to compute numerically. But for those ones, it probably is very difficult to match the observed volatility structure. But for process that are multi-factors, they're much more computationally intensive and typically do not have analytical solution, but they have enough flexibility that allows you to do a lot more things. You can, you can match the interval structure. You can also match the volatility structure. So really, as we know in when you start to price options or complex derivatives, you'll see that a lot of time you have to make a choice, a trade-off between analytical simplicity and the richness of the model that matches the structure. So that's something that you always have to fight and to make a conscious decision about.